All right, let's talk about one of the biggest things you can do to speed up your Apache Spark jobs. Seriously, if you want your code to fly, you absolutely have to understand the difference between two kinds of operations, narrow and wide transformations. So let's dive right in.
You've been there, right? We all have. You write a Spark job, it looks pretty simple, you hit run, and then you just sit there, watching that progress bar crawl. What is actually going on under the hood that's making everything take forever?
Well, 9 times out of 10, the problem has a name. It's this one, single, incredibly expensive operation called the shuffle. Think of the shuffle as the main villain in our Spark performance story today.
So, to beat this villain, we first have to understand it. What in the world is a shuffle, and why does it create such a massive performance bottleneck?
Okay, picture this. Spark is smart, so it breaks your huge data set into smaller chunks called partitions. It spreads these partitions across a whole bunch of different computers or nodes in a cluster. A shuffle is what happens when Spark has to move all that data around over the network, trying to get related pieces of data onto the same machine. This means it's writing data to a hard drive and then sending it over a network cable, literally two of the slowest things a computer can do. But what if you could just not do that? What if you could avoid that whole expensive data-moving mess? Well, that's where the hero of our story comes in, the narrow transformation. This is your secret weapon for writing lightning-fast Spark code.
And honestly, this table right here breaks down the whole concept perfectly. On one side, you have narrow transformations. They have a really simple one-to-one relationship, they don't need a shuffle, and, you guessed it, they're fast. On the other side, you have wide transformations. They've got this complex, messy, many-to-many relationship, which forces a shuffle, and that makes them way, way slower.
So let's get a little more specific. A narrow transformation is any operation where each little chunk of your output data only needs to look at one little chunk of your input data. It's a clean, self-contained job. Each computer in your cluster can figure out its part of the answer all on its own, without having to talk to any of the other computers.
And here it is, the magic formula. It's that simple. When there's no data being shuffled around, it means the entire operation can happen right there in the computer's memory. And that is what makes it so unbelievably fast.
And the cool part is, you're using these all the time, probably without even thinking about it. Things like map, filter, select, or with column, these are all classic narrow transformations. They just take the data in one partition, do something to it, and spit out the result in that very same partition. Simple, clean, and super efficient. Okay, and now for the other side of the coin. If narrow transformations are efficient, independent workers, then wide transformations are, well, they're a total coordination nightmare that forces everyone to stop what they're doing and have a big, slow meeting.
You see, with a wide transformation, to calculate the result for just one output partition, Spark might need to grab data from multiple different input partitions. It has to pull bits and pieces of data from all over the cluster just to get a single answer. That's where we get that messy many-to-many mapping.
And that's why it's so slow. To get all that data from all those different places, Spark has no other choice. It has to perform a shuffle. It has to hit pause, write a bunch of temporary data to disk, send it all across the network, and then just wait until everything is finally in the right place before it can even think about moving on.
The usual suspects here are operations like group by, join, and order by. And it makes perfect sense when you think about it, right? To group all the records that share the same key, Spark has to find every single one of those records, no matter what computer it's on, and pull them all together. That's a shuffle. Same thing goes for sorting data, or joining two different data sets.
Okay, enough theory. Let's see what this actually looks like in the real world. We're going to run a quick performance test to see just how big the difference is between a few narrow transformations and just one wide transformation.
And we're not messing around with a tiny data set. We are processing 10 million rows of data. This should make the performance impact impossible to ignore.
First up are narrow transformations. We'll do a filter and a with column. And the result? Just over half a second. Boom, done. That is incredibly fast.
Now, let's take that result and do just one single wide transformation on it, a group by. And whoa, look at that time, almost 3 seconds. The difference is just staggering.
This chart just says it all, doesn't it? That tiny little bar on the left, that's our speedy narrow transformations. That giant bar on the right, that's the performance price you pay for the shuffle introduced by that one group by operation. It's not even a fair fight.
So let's put a final number on it. That single wide transformation was 5.5 times slower than all of the narrow transformations combined. That is a gigantic performance hit, all from just one shuffle.
So the lesson here is massive. If you want to write seriously high-performance Spark code, you need to live and breathe by one simple golden rule. Minimize wide transformations and apply narrow transformations first to reduce data volume before shuffles. This is it. This is the whole game. Now, it's not about avoiding wide transformations completely. Sometimes you just have to use them. The secret is to be smart about it and do as much work as possible to shrink your data before you trigger that expensive shuffle.
So this golden rule really boils down to a super simple 3-step strategy. Number 1, always start with your narrow transformations. Use things like filter and select to get rid of data you don't need. 2, the goal is to make your data set as small as possible before you shuffle. And 3, if you have to shuffle, make it one of the last things you do. The less data you have to move, the less time you'll spend waiting.
And that really just leaves us with one final thought. Take a look at your own Spark jobs. Go on, find those group I's, those joins. Identify where the shuffles are happening. And then ask yourself, by applying this one simple rule of filtering first and shuffling last, just how much faster could your code actually be?